Everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. We'll be seeing the overview of today's session. Already we have discussed about the stack applications, one of it, and we have implemented also. Under that we have seen these four used in balanced parenthesis, used in conversion of infix to postfix expression, used in evaluation of postfix expression, and in compiler designers. Already we have completed this part. Already we have completed the theoretical part and the implementation of balanced parenthesis. Now we are going to discuss about the conversion of infix to postfix expression. Right? Now, before going to discuss about the conversion methods, first you need to know about what is an expression, how many different types of expressions we have, all these things we have to discuss. Okay. Now, what is an expression is? Expression is nothing but it is a combination of operands and operators. And what are the different types of expressions we have? In expressions, we have so many. Under that, we will be discussing about mainly the arithmetic expressions. We have binary expressions, ternary expressions all are there, but here in arithmetic expressions we are mainly categorized into three types. One is infix expression, the operator is in between the operator. We have three types of arithmetic expressions all there, that one we are discussing now, right? That is, these are the operands and this is the operator, and here these are the constant values, in between that we have an operator. Then we have prefix expression, it is also known as Polish notation. The other name for prefix is Polish notation. Here the operator precedes the operands. That means first we are going to have the operator, then that is followed by the operands. That is the meaning of it. Precedes the operands means. An example, plus this is the operator and these are the operands. Then we have postfix expression, that is, it is a reverse Polish notation. Right? In opposite to prefix, we are going to represent it. That's why it is named as reverse Polish notation. How we are going to define it? The operator follows the operands. That means first we are going to have the operands, then an operator is going to follow. That is 2, 3 plus or AB plus. This is how we are going to represent the postfix expression. And we have already discussed about what is infix expression. Let us see. What is the syntax for it? The operator is in between the two operands is nothing but the infix expression. The syntax is operand followed by operator and operand. And this is the example we have seen already. And let us consider we have given an expression 5 plus 1 into 6. Right? Without knowing any priority, associativity and BODMAS rules, if I want to calculate an expression, if I don't know anything regarding that. Right? In that case, how I am going to evaluate an expression? I am going to follow normally from left to right. I am going to evaluate the expression. That means first I am going to calculate 5 plus 1, that is 6 into 6, that is nothing but 36. Is this the correct answer? Is this the correct answer? No. Right? It is not the correct answer. Why? Because it is not the correct answer. When you are going to have different operators, there we need to check for some priority. That means here we are going to come across with the BODMAS rules. Maybe studied in your intermediate. Once you can refer it. That is BODMAS means braces, multiplication, division followed by addition and subtraction. Right? When coming to our programming, the same thing we are going to represent with the priority and associativity also. Okay, let us look into that. According to that, here star is having the higher priority compared with the plus. That's why first we are going to calculate 6. 1 into 6 will be calculated. Then we are going to perform the addition. That is how we are going to calculate. Now, for that I told you, right, we need to follow some rules. Those are nothing but the precedence and associativity. Now, what is precedence and what is associativity? Let us look into it. Precedence is defined on which operator is having highest priority, evaluate the expression accordingly. If I am going to have different operators, consider two operators plus and star. Right? In this, which is having the higher priority, we have a precedence associativity table regarding to their priorities. Right? According to that, you will be knowing the priorities of each and every operator, right? Based on that, you can refer that any of the books and you can check it. We have a tabular form so that you will be knowing the priorities of each and every operator. According to that, I have taken two priorities, plus and star. Star is having the higher priority compared with plus. Okay. Now, precedence means it will be first considering the higher priority operator. First that will be evaluated and then it will be taking for the operator plus. If you have seen the previous example, the same thing we did it, right? What is associativity? When you are going to use it? Now you can see the statement. If two or more operators are having the same precedence, then use the associativity to evaluate the expression. That means if I am having the same operators, that is plus and minus, are having the same priority, and you could look into star, division and modulo division, all these are having the same priority. In this case, in the expression, if you got these type of things, in this case, how I can evaluate the expression? In that particular case, you need to follow this associativity, that is from left to right and right to left. These are the two ways we can follow. And here I have mentioned few of them which are following the left to right and right to left associativity on operators. Observe here, the parentheses are having the associativity from left to right, and exponential is having from right to left. This is different, and the remaining all multiplication, division, addition, subtraction, all are following the same left to right associativity. Only few of the operators are following it. Once you can refer that table and you can evaluate the expression. And you can see some of the examples how you are going to evaluate it. Yes, here star, division are having the same priority, and two places we have, both are having the same priority. Now how I can evaluate this expression? See stepwise. First, star is having the higher priority, so that we are going to follow the left to right associativity. First, these two will be evaluated. 2 into 5 will be evaluated, right? In each step, we are going to represent them separately. Let us look into it. Next, the next higher priority is for division, that is 30 divided by 5. That is going to be evaluated. Next, we have plus, that is also first it is going to evaluate 1 plus 10, and then it will be evaluating 11 plus 6, that is 70. Now you have the exponent. Now it will be evaluated from right to left, right? That means first it will be evaluating 2 power 3, right? 2 power 3 is nothing but 8. Then it will be evaluating this 2 power 8 is nothing but 256, right? Here it is following the right to left associativity. Here all it is following with left to right associativity. Right. Here, if parenthesis is given, no need to check with the precedence associativity. If already in the expression, if something is given with the parenthesis, right, in that case, no need to check for any associativity or precedence. Nothing will be checked. Based on the parenthesis, you are going to evaluate them. And coming to the prefix notation, we have seen the operator comes before the operand. And this is the syntax where you can represent operator followed by operand and operand. And these are the examples we have already seen in the starting itself. And if you have given an expression like this, and how we can evaluate this. A star B plus C. First, this is the expression. This is, you consider it as A, AB, and prefix means you are going to represent it as first we are going to represent star AB plus C. Right, this is one statement, right, and this is first step. Next, I need to evaluate the remaining. That means again I am going to consider this as A and this as B, and this is the operator where you have. Now, accordingly, we are going to get this complete one. We are going to consider it as A and this is B, right? That's why A, B, C. These are the operands where you are going to place, and this is the A value and this is the B value and this is the operator that should come before it. That's why plus star ABC has to come. And in the same way, the postfix expression comes after the operands. So that this is a syntax where you are going to follow operand followed by operator. Then this is how where you are going to represent the example for postfix expression. The same thing, A star B plus C. How we can evaluate we need to take it as AB. A star B plus C means this is an operand and this is an operand and this is the operator. Postfix means AB star plus C. And still again we need to take it as this is A and this is B and this is the operator, like an infix expression. Now we need to represent in terms of postfix expression. How we are going to represent AB, right? Postfix expression. AB star C and plus. This is how we are going to represent, right? AB star C plus. If it is a small expression, then directly we can implement like this. And here we can given parenthesis, based on parenthesis, how we are going to represent an infix expression to postfix expression. Let us look into this. Is an implicit parenthesis that was given. We are going to consider the infix expression. For that we are going to place the implicit parenthesis. According to parenthesis, transfer the operators from the beginning of the parenthesis. Observe here. Here we have placed the parenthesis internally. So that 5 minus 7 internally means here we are going to represent it as a prefix expression, right? That's why we are going to place operator first, minus of 5 minus 7, right? For this case, for this parenthesis, star will come first, then 3 will be an operator, right? Next, for this one, we are going to have the division, right? That's why we are going to get the division next. Then lastly, we are going to have the last parenthesis. For that, we have placed the operator should come first. And after placing all of them properly, we are going to remove the parenthesis. This is how we are going to represent the prefix expression. In the same way, if we are going to reverse, in the same way, we are going to represent the postfix expression also. Remove the parenthesis, represent the operator at the end. Previously we have placed at the starting, now you are going to place it at the end, so that you can evaluate the postfix expression. But it feel a little bit difficult when you are going to place a parenthesis if you are not placing the parenthesis properly. For that purpose, we are going to have an algorithm to implement this conversion of infix expression to postfix expression. Let us see what is the algorithm. Initialize an empty stack. Then repeat the process until the end of the infix expression, right? We need to take an expression, consider A plus B into C. This is an expression that was given, right? First we have to take this and we are going to take an empty stack. Then we are going to check each and every character. In that, if I appear with a token may have constant value, variable, arithmetic operator, left parenthesis or right parenthesis, anything it can have. If the token is a left parenthesis, what we are going to do? We are going to push it onto the stack. If it is a right parenthesis, then we are going to pop and display the stack elements until left parenthesis found. Suppose you consider you have open parenthesis on the stack and you find some operators like this, and if I find the closing parenthesis, then I need to pop all these operators from the stack. That is the meaning of this right parenthesis when I am going to find, right? Then we are removing, popping all the operators from the stack, and then just we are going to pop the left parenthesis also from the stack, and we are not going to display it. We are going to remove this one also, but we are not going to display anything here. And if I find an operator, here it should be very careful when you are going to perform with an operator. Here, why? Because if the stack is not empty, the token has the lesser or equal priority than the stack top element. Then pop and display. And otherwise, what you are going to do? You are going to push it onto the stack. And if you find any operand, only operands like A, B, or if you find any constant values, we are going to push it onto the stack. That is, push it onto the postfix expression. Display it means in the postfix expression we are going to place it. Then when the infix expression is reached to the end, pop all the stack items until the stack is empty. If you have reached the end of your infix expression, then you are going to pop all the things that was present in the stack, all the operators that were left in the stack, that has to be removed and place it in the postfix expression. And here the left parenthesis in the stack has the lowest priority. And before check that the left parenthesis which you are going to represent, that is having the lowest priority here. This is a note which you have to remember. And here when you are going to see about this operator, you need to remember few things. If in the stack top I am having the plus operator and the incoming operator is star, just we are going to push it onto the stack. Okay, this is one condition which you need to remember. And the second condition is, on top of the stack I am having the star operator and incoming operator is plus. The token which you have, which I am scanned or encountered is plus. In this case, star is having the higher priority and plus is having the lower priority. In this case also, you need to pop star, you need to pop the star value and push this plus onto the top of the star. This is one case. And the third case is when you have the same priority values, right? Star and division are having the same priority. In this case also, you need to pop the top of the stack element and push this onto the top of the stack. That means star is popped out and division is going to be present on the top of the stack. Yes, these are the three cases where you need to check when you are going to perform this infix to postfix expression. And the overall summary about this session is, we have discussed about the stack applications. Under stack applications, mainly we have discussed about what is an expression, what are different types of expressions we have, different types of expressions. Then we have seen how we are going to convert infix expression to prefix and postfix without the algorithm, right? By using implicit representation of parenthesis, how we have done. And lastly, we have seen the algorithm for infix to postfix expression. These are the things where we have seen in the today's session. Okay, in the next session we are going to discuss about conversion of infix to postfix expression with an example, and we are going to try to implement a program on this. Okay, we are going to discuss about the program in the next session. Okay, thank you.